Hello everyone, welcome to the YouTube channel of Oiko Ipsum. This video is the first of the videos on intermediate statistics for economics. In this first video of intermediate statistics video series, I will try to explain the basics concepts of probability. Alright, let's get started then. Let me begin with an example for an experiment which paves the way for us to understand the concept of probability. So let's consider we toss a fair coin only for once. There are two possible outcomes. These are either heads, demonstrated by capital H or 1, and the tails, showed by capital T or 0. Now let me introduce an important term for the probability theory, that is sample space or capital S, which includes all possible outcomes of an random experiment. This experiment is an example of random experiment because we cannot control the factors which may affect the result of the experiment. The sample space S of this experiment includes H and T, while each of the elements of sample space S is called sample points. Now think for another experiment. This time we toss a fair coin twice. The sample space for this experiment includes heads, heads, HH, heads, tails, HT, tails, head, TH, and finally tails, tails, TT. Or if we would like to demonstrate these sample points by numbers, we can list them as 1 1 heads heads, 1 0 heads tails, 0 1 tails head, and 0 0 tails tails. Listing by numbers enable us to illustrate the sample points in a Cartesian diagram. Now let's we put the sample points in the Cartesian diagram. First we put 0 1 means tails and heads, and then 1 0 means heads and tails, and then put heads and heads means 0 and 0. Lastly, we put heads and heads to the Cartesian diagram as 1 and 1. So far, we have learned the terms of random experiment, sample space, and sample points. Now, we are going to learn what the events mean in the framework of probability theory. But before that, we will set the intuition behind what the events means. So we should first have a look at what is the chances for only two heads occurring in an experiment which we toss a coin twice. To be able to understand that, first we should have a look at set operations. Now think that we have two different clusters, cluster A and cluster B, and these clusters have three different elements. These are X, Z, and Y. Using this example with clusters, first we define A union B. A let's say capital U as union and B is equal at X plus Z plus Y, meaning that A union B on all the elements X, Z and Y. So what about intersection? A intersection or inverse of capital U B is equal only Z, meaning that the both cluster A and cluster B own the same element, that is Z. So what about complement? A complement, this superscript symbol over A is equal at Y, meaning that there are three elements, but between the three elements A does not have Z, only Z. What about A but not B? A minus B or A inverse of capital U B superscript is equal X. And this is the opposite of A complement. Now that we have learned about the set operations, we can investigate what happens when only two heads occurs. So here our event is two heads occurring. We can show this as a sample space. Let's think as brackets two heads. Here two heads in front of the brackets of capital S means the event. So the sample space for two heads occurring is only head in an experiment which we toss a coin twice. Only H and H, and it is also equal at 1 and 1. It is very easy to demonstrate the event of two heads occurring in a Cartesian diagram. So for the both tossing, we have the result of 1. So we will choose the ones from the both axes and make them connect in 1 1 coordinate. So this is HH or 1 1. So the events of two heads occurring is equal at 1 1. Now think that we demonstrate the two heads occurring in a cluster approach or this using set operations. Let's say that event A is two heads and event B is two tails. Now think that these are two different clusters, cluster A and cluster B. So let me draw this event using the clusters. As event A or cluster A only consists of two heads or HH, and as event B or cluster B only consists of two tails or TT, these clusters doesn't have tail head and head tail. Hence, cluster A equals at HH, cluster B equals at tail tail, and cluster A intersection cluster B equals at empty or nothing or null, and what cluster A doesn't own is equal at tail tail, tail heads, heads and tails. So what about what the cluster B doesn't have, and these are equal at heads heads, tails heads and tails tails. And what the cluster A own but not cluster B is equal heads heads, and what the cluster B own but not A is equal at tail tail. This brings us to the end of the lecture. Don't forget to push the like and subscription button, and please visit oikoipsum.com. I will see you in another video, and this video will be the following video of this lecture. So take care and see you in another video. Bye.